In this video, I want to have a look at absolute value graphs. So the most basic absolute value equation is y equals the absolute value of x, and its graph looks like this. You could see that if we draw up a table of values, so if we had our x values and our y values, we had -2, -1, 0, 1 and 2. The absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And the absolute value of 2 is 2 as well. So we've got the points -2, 2. So -2, 2 is right here. -1, 1 would go here. 0, 0. And then it comes back up the other way. So it's symmetrical. It's an even function. So 2, 2. So you can see it comes in a straight line down this way and then straight back up. We want to have a look though at how we can transform that. So if we had the equation y equals the absolute value of 2x instead, that's going to make it twice as steep. So instead of going through 1, 1, it's going to go through 1, 2. So it's going to go through this point here and -1, 2 as well. So that means our graph is going to be much steeper. But it would still be two straight lines and it would still be symmetrical as well. If we have a look at how else we can transform it, if we've got the equation, for example, that y equals the absolute value of x minus 5, that -5 in there with the x is going to shift our whole absolute value graph 5 units to the right. So instead of its vertex being here at 0, 0, it'll be over here at 5. So it'll still be that V shape, but it'll be over here at 5 instead. And if we had y equals the absolute value of x plus 3, that plus 3 on the end, so it's not in with that x, it's not in the absolute value signs, it's on the end there, that's going to shift our graph up 3 places. So again, instead of going through 0, 0, it's going to go through 0, 3. And it's still going to have that same V shape. So that's a few examples of absolute value graphs.